Okay, so this little app demonstrates the physics behind a neon light and another discharge lamp, and it's it's one of the ways the first people discovered that energy levels in atoms were discrete. They couldn't the electrons in an atom just can't take on any old value. There are certain quantized values, and the way that that works, I'd click on spectrometer. So this is the wavelength. So essentially, there's click on continuous. So here's an electrode, and here's a anode, and the electrons are going through this vacuum chamber, and they're hitting the atom. And here's the excited. Here are the energy levels in units of eV, electron volts, we do in atomic physics. And here's the ground state to 4. And for certain values of the battery, you'll see that if you dial down here, then you don't get any photons. And if you move the energy up, let's go a bit higher, well, the voltage up here, then this accelerates the electrons up to give them enough energy that occasionally photons will come off. And you'll see down here you'll end up with a little bit more on. But here you'll end up with spectral lines coming out. And so you see a blue line here which corresponds to a photon, and the purple line here and the line here, these are photons, and they come flying off, but they only have certain discrete energies. And you can actually calculate them because you know the discrete energy levels, and you know the transitions are from one energy from the excited state to the ground state to a lower state. This gives you an energy difference, and with the energy difference you can work out what the energy is of the photon using some kind of equations from quantum mechanics. There's no complicated maths involved, it's just simple just plugging numbers into formulas, and you get a little kind of spectrum. In the spectrometer, so the idea of the exercise is just so you understand from this process is to try and make sure you understand where these numbers come from. So here you have a number around 400 nanometers, a number just below 500 nanometers, something here about 650, and you can actually use this energy spectrum to compute these numbers. And this sort of gives you a starting calculation of kind of how quantum mechanics works. And in physical applications, this is how people, these little light, these spectral lines, I'm calling here, when people look at stars, this is how they determined whether what the elements were in stars and different galaxies. Okay, and it's also worth thinking about this electron production. You can dial that up or down, and if you change the voltage, this changes the energy of the electrons, and you can see what happens. And if you so wish, you can move the atom around, doesn't really help you. And one of the things occasionally it's kind of useful to run in slow motion. Okay, so just recall, the aim of the exercise is just to try and calculate where these lines are using kind of the basic ideas of the energy levels of hydrogen and the energy of a photon with given frequency.